Okay, first lesson in our vectors chapter is Introduction to Vectors. Okay, so a vector is a directed line segment. One way it can be represented is by a column vector. So you might have seen this before. So here I've got 4, 3. It's in square brackets. What that represents is the 4 is my horizontal movement and the 3 is my vertical movement. So this means 4 across and 3 up. And then this line here is the vector itself, which is called V. Now, a few points. We can represent vectors by a single letter. Here, you'll see that I have it in bold, and that's how it will be in your textbook. But when you're writing it, it's not so easy for you to write in bold, so you need to underline the letter with a tilde, like so. It's really important that we know what letters are representing vectors and what letters aren't. So it's a way to distinguish between them. When you're drawing a vector, it's just the line that you draw with an arrow on it. Sometimes the arrows, we put them in the middle like this. This is just for me to show you what it is. Okay, so just have a quick go at drawing these vectors. On the same graph, it just means on some squared paper, but as long as you, on your lined paper, use a decent enough scale, that would be fine. So I'll just quickly go through these ones with you. So 1, 5 is going to be 1 across and 5 up. 0, 2 means no horizontal movement, just 2 units down. -1, -2 means I go back 1 and down 2, like this. And then -4, 3 would be going back 4 and up 3. So it would look something like this. Obviously, I don't have squares there, so my scale isn't spot on. You should get an idea of what we're after. Okay, here I'm defining the vector as a movement from the coordinates 2, 6 to 3, 1. If I'm representing U as a column vector, I need to find the numbers that A and B represent. So let's have a quick diagram. Here's A at 2, 6, here's B at 3, 1. This is my vector here. So you should already have an idea in your head of whether your A is going to be positive and negative, and whether your B is going to be positive or negative. Now to find it, it's where I end up, subtract where I started from. So 3 minus 2 and 1 minus 6. So that gives me 1, -5. And that makes sense, doesn't it? I've moved 1 across, I've gone down 5. And it says find A and B, so it's always good practice to, when answering a question like this, state A equals and B equals. Another way we can write vectors is as 2 capital letters with an arrow on top of them. Here, I'm going from A to B, so it's AB with an arrow pointing. If I were going in the other direction, then it would be BA. And obviously my vector would be different, it would be -1, 5. Have a go at these 4 questions now. Pause the video while you do it and mark your work. So we can do arithmetic with vectors. So adding vectors to produce a resultant one. So if I move along A and then B, that's the same as just moving along this vector here, B plus A. And it doesn't matter whether I go A and then B or B and then A. I'll end up at the same place. The resultant vector is the diagonal of the parallelogram created by them, the 2 vectors. Now vector addition is commutative, that's what this says. So we can do A plus B, we can do B plus A. Either is fine. We can also multiply a vector by a scalar, which is a real number, to change its length. So if this is vector B, then 4B is just going to be 4 times as long, going in the same direction. We can say that two vectors are parallel if there is some real number that's not 0. That means that the multiple of one vector is the other vector. So a negative vector goes in the opposite direction. So if I were to multiply by a scalar of -1, for example for b, that would just be this. So this is the vector -b. The way we subtract vectors is just by adding their negative. For example here. Okay, and finally in this section, a 0 vector, 0, that's bold 0 there, is a line segment of 0 length and has no direction. Let's have a look at some examples of vector arithmetic then. So I've got my two column vectors g and h there. What happens when I add them together? So I just add the horizontal movements and add the vertical movements together. So 2 plus 2 is 4, -3 plus 0, -3. Subtracting. Similarly, subtract the second horizontal movement from the first, subtract the second vertical movement from the first. So 2 minus 2 is 0, -3 minus 0, -3. Multiplying by a scalar. So this 3 multiplies both the horizontal movement and the vertical movement. That gives me 6, -9. Here I've got some multiplication and subtraction. Gives me this. Just like in algebra, I'm going to evaluate the multiplying part first. So that gives me 4, 0. Then I have 4 minus 2 is 2, and 0 minus -3 is +3. Okay, have a go at these 4 questions now. Pause the video while you do it. Make sure you mark your work. Okay then, so let's have a look at how we can use these vectors. Here I've got a square. Actually, I'm not going to read it to you. You can read the question for yourself. Okay then, so OQ, to get from O to Q, I can't move through the middle of the square like this. I've got to follow edges that I know. I can go from O to P and then P to Q. I know that OP is the vector P. PQ, this is a square, so I know that the sides are the same length and that they're parallel, or PQ is parallel to OR. So PQ is the vector R. And that's that. To get from P to X, I'm told that X is the midpoint of the side PQ, so it's just half of PQ. As we found before, PQ is the vector R, so PX is half R. And then to get from O to X, I have to go O to P, P to X. So O to P is the vector P, P to X, which we've got here, was half R. Give you a moment to read this one. Okay then, so to get from A to E, we need to go A to O, O to E. Now, OA is the vector little a, so AO is going to be negative A. Then O to E is just E. It's fine to write E minus A as well because vector addition is commutative. AD then. So to get from A to D, it's the same as twice OE. Now, if you're not convinced by that, we're told it's a regular hexagon. That was a bit dodgy. Regular hexagon you can split up into 6 equilateral triangles. So this edge here is equal to this here and this here. So AD is 2 times OE. OE we know is E, so that's just 2E. That 2 shouldn't be bold there. I've just noticed that. You would be writing this, negative A plus E, like that, okay? AP then. So I'm told that AP to PD in the ratio 1 to 2. So the length AP is 1/3 of the length AD. Now I got over here that AD was 2E. 1/3 of 2E is 2/3 E. It's preferable to write the fractions separate from the letter rather than having 2E over 3. It will just help with more arithmetic later, but it's not incorrect to write 2E over 3. Okay, for AB then. So I don't have a horizontal vector in this diagram, so I've got to work out a way to get from A to B using vectors that I have. Now, let's have a look at this then. So from A, I can go to D, then I can go to C. We can see that DC is parallel and equal length to OA, so DC is the vector A. Then down, CB. CB is parallel to OE, but our vector E goes from O to E, so we want to go in the other direction, so that's negative E. So I've got my AD, which is 2E, plus DC, which is A, minus E. Then you can see I've got 2E and I've got minus E here, so I can simplify to E plus A. And actually, if you imagine, if I go a vector E from here, then a vector A from there, it's like travelling along those edges of that equilateral triangle that I showed you earlier. Okay then, OB. So now I know AB and I've got OA, OB, super simple. OA plus AB gives me A plus E plus A, and I can simplify that by writing 2A plus E. Okay, have a go at questions 11 to 17 now. Remember, any questions that you've got, you can post in the discussion and make sure you mark your work. Thank you.